Right, hello there. Third time is a charm or lucky charm. AMD drivers, they don't like playing video and doing streaming at the same time. It'll crash them. And that's what the problem was. It did that twice, so I had to update all sorts of things. But anyway, so today is just going to be a follow-on from the last Hangout that we did. So in that one, we were looking at setting up an animated accessory. And basically, we've taken one of the accessory starter file armatures and modified that by adding a couple of bones to it. So we duplicated these two from this skeleton, well, from the existing bones of the armature. So we duplicated them and put them into position and then animated our, well, it's a pet, but it's actually an accessory, glorified accessory. So that's the easiest way to make a skeleton from an existing armature. You're basically just duplicating bones and moving them into position, and then you can do whatever you want. But that then raises the question, well, what happens if you already have, where is it? There it is. Don't save. So what happens if you already have a skeleton built and it's associated with, again, this is a pet, but it's actually an accessory that's positioned relative to the avatar, but it's not linked to one of the accessory skeletons. So what do you do in that instance? There are two ways we can solve this problem. So create your armature, get it animated the way that you expect it to animate. So that's all you need to worry about with respect to the product itself, or the item, this thing that people will actually see when they are in IMVU. So get that set up as you would normally do. Hang on. Just double check the videos. Pause all of those. Right, so yes, get your object set up. So you've got your skeleton, however you want to create that. So normally you would be just dropping in, where is it? An armature. And then modifying that to accommodate whatever your object is supposed to be doing as an animation or as an animated thingamajig. And then depending on the item itself, in terms of where it is going to appear, we can solve this disconnect in two ways. We can either use an empty object. Let's go back into the 3D main layout. We can either use a empty object. This would be similar to the nodes that are used for furniture and room items. And what we would do is parent the existing skeleton, or the pet skeleton. We would parent that to our node and then export the two, including the mesh, as a unit. The second option is to select your skeleton and select the node, well, not the node, the root armature for your accessory. So in this case, it's female O3 master root. So we're selecting that and we physically join them together. So it creates one big armature. So these wouldn't necessarily move, but these will because they've been animated. So it keeps all the animation data and everything else, but all we're doing is correcting for the fact that we don't have the attachment root and attachment node sections or components of the armature. But using either approach, there are issues that you have to be aware of. So today what we'll do is just go through the two and sort out the problems, or we'll take a look at some of the problems that need to be solved when we export and set this up and assemble it in Studio. So let's take a quick look at our object. So it's been animated. So it's got a full set of animations. So there are quite a few, and all of these will be exported when we export this for IMVU. So one of the reasons why we have to, why is that doing that? Oh, that's right. One of the reasons why we have to do this, we have to use one of the armature skeletons as our root, because if we don't, what IMVU will do is use the bone that sits at the top of the object's skeleton. So let's go into the hierarchy. Select our skeleton. Where is it? Oh, that's it there. So what it'll do, so we'll just expand all the bones. What IMVU will do is when it's importing, it'll use the bone that sits at the top of the hierarchy as the anchor point, or the element that anchors to the bone of the avatar. So for example, the root bone of the pet, when imported into IMVU without using any of these, it'll use this bone in place of this bone. So what we'll end up with is the pet sitting between the legs of the character, of the avatar. It'll still animate, but it'll be positioned incorrectly because IMVU is using that bone instead of this one. So we have to make sure that we set up our anchor point so that we get the correct distance relative to the skeleton that we've got set up for, in this case it's a pet, but it's the same for any type of object, whether it's a set of earrings, bracelet, a tail, doesn't matter. So we've got our fully animated object. And what we can do actually, just to show this in practice, is just export this. So select the mesh components and the skeleton, file, export, FBX. Selected objects, that's all right. Geometry, that's all right. Armature, always disable. Add leaf bones, and again, because we are including animation, we need to disable NLA strips and force start end keying. There's a reason for disabling those, and it basically boils down to forcing the animations into their own tracks, in the same way that we have tracks, we have channels for each bone, and we have action sequences for each action. So that's our idle action. With those two options disabled during export, what we end up with is a set of sequences in the FBX file that are seen or interpreted as being separate from one another. If we don't do that, it'll tend to include all of them in a single track and then mark where the start and end point of each sequence is in the same track. IMVU has difficulty with that kind of animation action data. So this is why, whoops, when we export, let's double check, mesh, skeleton. This is why when we export, selected, that's all right, armature, disable. That's why we always have NLA strips disabled and force start end keying disabled. So clear the checkbox, file name, file location, that's okay, and then export. So if we do studio, got a derivation already set up here. This is just the glasses, but if you want to create a new one, just create and then go through the process. Oh, we've got MTML accessory there now. That's changed. Where are the glasses? Let's close that. So we've got our character, just import FBX. Find the file, which is number 4. So preview of the contents of the file, 0.01, root 10 bones 2 meshes. We've got 2 meshes because the roll and the collar are separate. Next, those are our images. These are our animation action sequences. So it's bringing all of those in. Preview, import. And it's brought it in, as usual, sticking it on the head node. So we have to change that. Component, skeleton. So we need to change the node. Female 03 master root. So this is the anchor point. This is the bone in IMVU that's down here. Not IMVU, in Blender. So that's this. But because we haven't connected the pet's armature with this, what should happen is the pet appears between the avatar's legs. Now, that's okay if you want the pet to appear there. So it also then means action. Let's create a quick stance.idle ensemble idle loop forever apply. So it then means whatever it is that you're animating animates relative to that position, again because let's enable the skeleton. Don't know how easy this is to see, so let's change the room. That's a little bit easier to see, but we've got our pet skeleton, but it's using the root bone that's down here instead of female O3 master root, and that's why it's positioned where it is. But what this also means is that because it's doing that, if you have an animation sequence that has the avatar, not the avatar, the pet, which one is it? That one. So most of the sequences have the avatar have the pet stay put, but this one, which is the character sneezing, has the pet moving away from its root position. And if we leave the project set up the way that it is, so that IMVU is using that bone, this can mean, I don't know if it will do it this time, but this can mean jump, jump, 1, apply, preview. So we're just going to test the sequence. So we're going to type down in here, jump. Whoops, that's the wrong one we want. Sneeze. Where is that? There it is. So it did the animation, but it's stuck in place. It hasn't moved. So what should happen is it should jump back to here. But because we're using the root bone of the pet skeleton, it stays put, which we don't want. So it plays the animation, but the pet doesn't move. And this is because, and this is why we use the accessory file when we're creating accessories, whether that's jewelry or whatever it is, because these skeletal proxies, so each one of these is a proxy for a bone of the armature of the avatar. These act as positional targets. So anything that you animate that doesn't move, well, if it moves from its original position, IMVU is using the root armature that stands in as the proxy for the skeleton as the root for the position of your pet or your object. So the position of this, in terms of what we're doing in Blender, for example, doesn't have to be in Blender, but this change of position is in IMVU relative to this. So without this, we don't get this. And this is why we have to set up our objects to have, or to be based on, the Armature proxies in the accessory file. This is why we have to use them. So that's a long way round. That's a long round way. That's a long way around explaining why we have to use these bones and what it does in terms of animating objects. So back to the topic. If we've created our object with a skeleton and we haven't associated it with an armature or a bone proxy, we can parent our skeleton to a node, or we can join it to an existing armature. So if we do the first one first, the parent to a node, we'll see what that does. So that's all we're going to do. So we're going to select the armature, select the node, and if this doesn't exist in the file, and if you want to drop one of these in, let's add, where is it, empty, and then you'll get a lot of shapes. You can use any one because these are essentially just different representations of a positional marker. So the origin, this little dot, that points out the location of the object in 3D space. So if we were to move this, we'll see the x coordinates in this particular example change. Oh, and we have already got it connected. Undo. Let me just undo that. So that's Alt P. Okay, transform. Right, so if you're using a node, drop your node in, make sure it's renamed female 03 master root so it approximates the actual armature, and then select your pets armature or your accessories armature, shift click, select the node, and then we're just going to hard parent them. So parent object, and then we'll get the little pop-up. Make sure type is set to object and keep transform is active. There's a reason for that, which is outside the scope of this, but keep transform, that's okay. So what we should now do is, or what we should now have is, if we click the armature, not the armature, the node, press the G key, the armature moves with the node. That tells us that the two are parented together. So we need to just double check that the mesh is parented to our pet armature. Select. It is, but we need to hard parent it. So select the two meshes, shift click, and then the armature. Parent, object, keep transform. So this now means that if we select the node, everything moves. This is explained in the previous Hangout why we do this. So once we've got all of that set up, let's just save this, save as. Right, export. Mesh, This was, let's rename this actually. Let's call that pet.mesh. And we'll call that collar.mesh. You don't have to export the meshes separately. We'll do it for clarity. So select our meshes and we can see the hierarchy. So the node is at the top of the tree as female O3 master root. Then we've got the skeleton. So the parent relationship is between objects in this particular instance. So we've got the armature object parented to the node, and then the meshes parented to the armature. Hence the way that the hierarchy is structured. So that's the top indented. Right, so meshes, armature, node, export, FBX, number 5, selected objects, everything else is okay, that's alright, again that's always disabled, and again NLA strips, force start end key disabled. Export. So let's get this into Studio. So we'll keep this file open as a reference. Oh no, we'll have to save this actually because it won't let us open the same file. Save as right, home, click on derived again. Oh, we just saved that. That's weird. So we have to excuse the idiosyncrasies of Studio. There we go. So import FBX number 5. So let's preview. Brought in more animations this time. Not sure why. 0.01. So now we've got two options here. We'll do what we normally do with accessories, and that's selecting the one with the fewest number of bones as our skeleton. So we'll do it with this one first. So 10 bones, 2 meshes. Next, next, next. So it's brought the toilet roll, the monster, plonked it at the head, and we can already see the fact that the monster is where it is means that there's something wrong with the skeleton. So we can double check this. Female O3 master root. So even though we set the project up correctly in Blender, so these are all parented together, we've got the same relationship, and we've exported them as a group, doing what we normally would do results in this. So let's just set up a quick animation just to make sure that this does work. Apply, preview, and it is animating. So let's just save this. Whoops. Let's close that one, because you can only have 3 of these open at a time. You can only have 3 panels open at any one time. Let's rederive. That's a bug. That's an annoying bug. It must be holding the file or the project in memory or cache. Right, import. So this time what we'll do, so we've got our preview. This time we'll leave it using female 03 master root, 12 bones, 2 meshes. So this would be the only instance in which you would do this. Normally you would choose 10 bones, 2 meshes, the lowest of the 2. But because we're using a node as a proxy for the skeleton, what IMVU is doing, or what the FBX file is doing, is it's seeing, it creates a hierarchical structure where each element is a bone within the hierarchy, and those are added to the bones that are actually in the skeleton. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 10 bones in the armature. We've got the armature itself, and then we've got the root node that acts as a bone. Well, it's a node, not a node, that's the wrong word. It occupies a position within the hierarchy. So it's this. So actual armatures are seen slightly differently than structures, hierarchical structures that use nodes. But so 03 scale 0.01, whoops, mesh, that's all right. Next, textures. Well, those are the actions. Review, import. And this time we can see already that the pet is down here. It's still anchored to the head bone, but because we've got that distance, and because we've now used the hierarchical structure in the FBX to create our skeletal relationships between the objects, when we import that, it's now positioned correctly, well, relative to the head at the moment. So we'll change that. Female 03 master root. And we now see the object in place. That's where it should be. And double check the animation. Action. Stance.idle. Zero. Apply. Preview. So that works. So what we need to do next, sneeze. New ensemble. A chew. Just the once. Apply. preview. And then if we type sneeze again in the trigger testing box, we should now have the pet actually move. So it does. And this is what was meant about using, so this is why we have to use these bone proxies. Although they stick out all over the place depending on what bone they represent, that's why we have to use them, because our accessories, if they move from their anchor point, which are the skeletons, if they move from those positions, they won't work without these bones. They'll stay put, they'll animate in place. Let's just change that to the action editor. Expand that. Home. So, without using, well, in this case it's a node, without using the node as our anchor point, this animation doesn't move. It animates, but it doesn't move its location, because it's all relative to the origin of all the objects that are part of the project. So that's the first way, using a node. There is one other thing to be aware of if you do it this way around, and that is that your animations may not work correctly because of the orientation of the bone or the accessory, not the accessory, the armature proxy. The orientation of that may determine how the animation is positioned once in IMVU. So this is the downside to using nodes. It's quicker for projects that are perpendicular to the grid, and that's basically just female O3 master root, and I think pelvis node and head. I think they are the only ones that are perpendicular to the grid. So be aware of using nodes in this way may not work as expected, because the animation won't be orientated correctly in IMVU. Right, so the second approach is obviously then, as we said at the beginning, using one of the armatures. And this in some ways is a bit easier to set up, because all we're doing is joining the two armatures together and then exporting the entire single unified armature. Right, so that's still working. Now the downside to this is that when you join your armatures, we need this one to be the priority object of the resulting unification. So female O3 master root, that has to be the name of the object. But when we do that, so let's do it, shift click the armature, shift click the accessory armature, and then from object we just want join. That will join the two objects together, and it'll shift, it may shift our meshes across like this, because the position of the object is relative to the origin of the armature. So because we've joined the two armatures together, we've shifted the origin. So if we undo that, don't know how clear this will come out on screen, but the two armatures have their own origin point. So that one has an origin there, and this one will have an origin here. Let's see if we can enable origins all. So there's the origin for that, there's the origin for that. So our meshes are parented to this armature, but its position is relative to the origin. So when we connect these two skeletons together, the skeleton then uses our primary armature origin point, which is that, and that will jump any meshes relative to this origin point. So what we can do to prevent that, or limit what happens when we do that, is just select the meshes, object, where is it? Parent, clear parent, and keep transform. So object, parent, clear parent, keep transform. So this will destroy or break the relationship between the objects, the meshes, and the armature, but it will keep everything in position or in situ where it is. So if we move the armature, it won't then move the meshes. Oh, we've still got the connection between these. So let's just do the same thing again, but clear the parent for that. So now we lose the dotted relationship line. And we can double check, just clicking that. Right, so that's a little bit of prep. So skeleton or armature, shift click armature, objects, join. And this time it should do it without doing anything to the meshes. And it has. So what we can then do, meshes, armature, because again the origin has shifted. So now when we parent everything together, when we parent these meshes to this armature, it's now going to be parented relative to this origin point. So parent, object, keep transform. So now we should have this skeleton, or this armature now controls the mesh. But we have to double check something, because these meshes parented to the pet armature originally using its name. So this wasn't called, this armature wasn't called female 03 master root. So that now means likely that if we animate this, so it's the same skeleton, the mesh doesn't animate. So we have to fix that problem. So select the mesh, double check, it's dropped the object, which is the target, eyedropper, and just click on the object. Same again for the other mesh. And we still probably won't get any animations because the actions that we had, those were associated with the armature before it was joined to the accessory armature. So all we need to do is just select the armature, action editor, and just click on any one of our already set up sequences. And we now have our animation back in place. So we've now created the association between our skeleton, which is where is it? There it is. And we can expand that and we can see the bones. And our pose. So that's our animation sequence. We've got idle and then all the others. They're called something else there though, but so just check. That's the idle one. Jump. No. Happy. Sad. Walk. And yes. So we should now be able to export this. And let's just save this. File, save as, number 6. So same process for exporting, or similar process, but this time we are selecting our meshes. So shift click and then the single unified armature. So we don't have to do, oh, one thing we do have to do actually before we export. So we've created a relationship between our meshes and the armature, and all of these bones are already set up with a relationship. So that's the root, and then all the bones are connected to it. But when we joined this armature to this armature, we also need to create a relationship, a hierarchical structure between those. So skeleton, edit mode. So we want root. We want that connected to, what would it be? Attachment root. So bone properties, and we want the parent section. Click on the bone, and then we'll have our option, attachment root. Click on that, and it creates our relationship line, which is this dashed or dotted line. So from head to tail. Because that should now mean, if we go into pose mode, so that's attachment node, and that's attachment root. So if we don't do that, that's attachment node, that's attachment root. So without that relationship connection, attachment root doesn't control the pet or the armature, the accessory. Whoops. So we have to make sure that we get that set up. Right, so now just save over. Now we can export. So mesh, skeleton, file, export, FBX 6. Selected objects. That's all right. Again, always disable add leaf bones, and again NLA strips and force start end keying. That's okay. Export. So what we should find this time, so let's save this. Close that, close that. Let's do that again. New derivable. Import, whoops. Number 6. So again, it's giving us a different number of animations this time. So this time we've got 3. So let's try root 10 bones, 2 meshes. Scale 0.01. So this is what we would normally select for accessories. The lowest of the set. Next. Textures are okay. All these animation sequences. Right, so it hasn't brought it in the correct position. It's got female O3 master root. Whoops. Attachment root. So that didn't work. So let's do import again. Number 6. We'll use the second one, attachment root 12. 12 bones, 2 meshes. Oops, mesh size 0.01. Right, and this time it has done it. So the difference is, as we saw with using the node as the root. So how many bones have we got? Whoops. So we've got 12 bones down here at the bottom. So our skeleton, or the bone hierarchy, has 12 bones. So we have to be careful, even though we would normally select the lowest set, or the lowest option, so root. In this instance, where it's showing 3, we can use the middle one. We could probably use the top one as well, but that will probably reposition the object, the project, somewhere else, because it's counting the root data entry of the FBX file itself as a bone of the skeletal hierarchy of the pet. So if you get into this situation, just go back into Blender and double check the number of bones that are in the skeleton, and then use the option that's closest to that in terms of the number of bones that are represented. Cancel that. Female O3 master root. So that's the pet correctly positioned. Let's turn on the skeleton. Let's use the darker room so we can actually see that. And there is the skeleton. So we can see the relationship. That's the root bone, and then obviously there are the bones of the skeleton itself. So that's a more, let's actually just do the, that's a more advanced follow-up. Let's set the animation. Starts. That's a more advanced follow-up to some of the issues you might encounter when working with animated accessories. Oh, and then of course we've got this. So what we can do here is close that. Assets. Mouse over your entry. So this little ellipsis menu pop-up appears. Click on that, rename, and then just rename. So we don't have this bit that doesn't fit in the properties box. So we're having to guess what the animation sequences are. Walk.action. And final one. Oh, that was the final one. So we can also rename the skeleton. So now, ensemble. So we've now got names that we can actually work with. So idle, infinite, apply, preview. There it is, animating. So then let's create another one for the sneeze. Check the position of that. Just the once. So again, remember everything is relative to the root bone of the armature. So female O3 master root, which is connected to the root bone of the pet. So let's try sneeze. And there it moves. So that's what we were looking for. So that, that's a much more advanced deep dive into setting up your armatures for animated accessories if you created your accessory without using one of the accessory files default armature proxies for the avatar's skeletal bones. So in other words, if you create your project first, animate it, get it all set up and positioned, and you forget to use one of these, you've got two options to connect it to IMVU in a way that it'll work correctly or position itself correctly. So one was the node, so dropping a node into place, and two, which we've just covered, is using an armature from the accessory file. And of course you should be using the accessory files to build your accessories, because obviously if you're making your project in a standard Blender file, you're basically overcomplicating the process, because you've then got other steps that needs to be considered to append the file and make sure that it's all correctly set up relative to IMVU and the scale IMVU uses, especially if the object is animated, because just scaling an object up that has animations won't always work. It can break the sequence or the action. So that's an important aspect of making animated accessories, is to always start using always start making the project using the accessory starter file. You don't want to be appending animated projects into the starter file and then having to scale them up, because the scaling process will break the sequence. But that is the follow-on from the previous videos, previous Hangouts that we did. And we shall call it quits there. Until the next project, which I'm not quite sure what that will be. So yes, if you've made your skeleton, your animated project, you can still export it without doing too much shenanigans, but there are considerations to doing so, either using a node or physically connecting it to an existing armature in the accessory file. Right, thanks for lurking, lurkers, and we shall see you on the next stream.